Hey, what's going on, guys? CMK here. So I'm running this poll asking you what kind of format would it be preferred for you to watch, to follow my new project. So I'm developing a chess program in my own assembly language that is intended to be running on the Arduino based computer I've released recently, and yeah, hence the question. So it's changing all of the time. So first it was more like development progress highlights, but then it was like the most votes for this long and boring live coding as is format. Anyway, now it's not really that clear. After just 10 votes, it's not really that clear what in particular you would like me to consider. So for now, I decided to make just an introductional video to what the heck is CMK Computer and what in particular am I actually trying to do with it. So I've developed what I call CMK Computer, which stands for CMK Computer. It's highlighted on my main, or it's hard to say which YouTube channel is the main. Sometimes chess programming is the main channel. Sometimes CMK channel is the main one. It's hard to say which one is the main. So on my CMK channel, I'm running a series highlighting how this CMK computer works. I was shooting the real hardware. So here is how the Chrome Dino game works on the real hardware. I've been making tutorials on how to program in the assembly of my own design. But anyway, just all I need to provide now is just a brief overview of what is that. So CMK Computer is a bundle of Arduino Nano or Uno. So it's, well, in my case, it's based on Arduino Nano, but you can use Arduino Uno as well. And in the online simulation, I'm using the Arduino Uno because that's just the template that is available there. Also, it has the 16x2 LCD shield, D1 robot, which is the Chinese counterpart of DF robot. And 4x4 keypads, 4x4 keys keypad to enter data to this computer. So internally, it has the 8-bit CPU emulator and the hex editor that are flashed into the ATmega 3 to 8 microcontroller, right? And programs can be entered either via typing them from this keypad or via serial port. And hence this computer can be programmed dynamically, despite the fact it's based on Arduino. So we have a CPU emulator, imaginary CPU, imaginary instructions of my own design, and we can either enter the machine codes or send the programs by a serial port and run on this piece of hardware. So we'll now have a look how it works online. But before that, here are some considerations in regards to the challenges that I have along with this project. So it has only 1K of RAM, right? So it has the stack. So stack points to the very last byte in the RAM and grows downwards. So the first 512 bytes are used to store the program instructions and variables, and they just made the way that you can load more than 512 bytes. Well, actually, you can load. The problem is that the program bytes are encoded as ASCII characters, and they are sent as an ASCII characters by serial monitor. And since the serial monitor in the Arduino IDE assumes to be sent in ASCII characters and not the raw bytes, that's the way to go. But it actually takes 2 ASCII characters or 2 bytes to encode a single byte that represents the program that is supposed to be running on the CMK computer. Hence, the entire 1K of RAM would be taken to grab those ASCII characters, and when then it gets turned into actually integers, it would be only 512 bytes. And then we can also use the rest of 512 bytes to share those bytes between the program variables and the stack. And this is exactly the case that I'm going for with this chess engine. So a few words on the layout just a bit later on. Let me just finish this kind of thing first. So the runtime environment of CMK Computer is hex editor running in infinite loop, but also apart from just typing the address followed by the bytes that you want to enter, it also supports commands. So you can load program via serial port, make a memory dump to serial port, clear the LCD screen, make the hardware or software reset, and inspect the memory, the 4 bytes of memory at the given address. So I think we're gonna have a look at all of these features along the way as this tutorial goes. And in regards to the actual assembly language, the machine codes and the user-friendly mnemonics, they are all listed here. So currently it's 41 instructions. So I've added this print character to the serial port because there is no other way to debug how the board array looks like apart from printing to the serial port, because on the LCD shell I only have kind of two rows, so it's not really that enough. So I'm going to be printing the board to the serial port. And here are all the commands, and it only takes one argument. So this is heavily inspired by the good old 6502 assembly, and whatever instruction has its description. And if you're interested to learn how to code in this assembly and what in particular you can code in this assembly, then feel free to reference my series Programming CMK Computer tutorials, which is available on CMK's channel. So for now, I just want to demonstrate how this works in a simulator. So again, if you want to watch how this works in real hardware, feel free just to check out this videos. There would be the link in the description below this one. And for now, I just want to show you how this works in the simulator. So this is the iframe source from the TINKERCAD project that I have. This can be forked as well, so you can either use this link. If you'll use this link, you don't even need to register anything, like to register a TINKERCAD account. You can just go straight ahead and working with the computer. For otherwise, if you want to change something, you can have a TINKERCAD account and go in there and try to alter something, things like that. So for now, I just maximize the CMK computer here. And here is the source code of the CPU emulator. And here is the execute function. Yeah, here is the execute function that takes the machine codes as an input, machine codes of my own design as an input, and executes them as the output, right? And here down below we have some functions to run this hex editor. So the runtime environment is inspired by Apple I computer, which was booting into the hex editor, and you could have just entered commands to either just how it works on CMK Computer, either just to enter the bytes to run them directly, or to load the bytes from a third-party source. Well, on Apple I this was the tape, and here just a serial port. Okay, so by clicking the Start Simulation button, I enable the computer. I just put this somewhere here, I believe. And if I say, for instance, like 0000, so the address of 0, I want to enter some bytes, random bytes. If I just enter some random bytes, by the way, yeah, all the layout of the buttons match what is there. Apart these two buttons, so this is E and this is F. So we have all the buttons we need to input hexadecimal numbers, so it's coded by hexadecimal numbers. So for instance, we just add a couple of bytes, and in order to actually make it flash there to memory, to get the bytes stored into the memory, we need to enter up to 4 bytes. If we want to enter less, then we just can replace the rest of bytes by zeros. But anyway, so here we just entered some bytes into the memory, and for instance, if I say FFFC, and the address I want to inspect the memory at, and here we have this, what is at the memory address 0000. So for instance, if I just want to inspect the memory address of, say, 0002, then as expected, we have the 2 bytes from the previous output, and then the next 2 bytes are 0. So this is the index 2, index 0, 1, yeah, index of 2, 3, 4, 5, etc. So there are many commands like we can clear the screen, for instance. We can go for a software reset, and all these commands are documented in here in the GitHub of the project. But the most likely how you would want to run this is by loading the program via the serial port, which is available here. So we can just maximize the serial port, since we're not going to be changing what is flashed into the Arduino anyway. So we only need the serial port to interact with this sort of a thing, right? So And yeah, one last thing. So it's just trying to write, trying to run those bytes that are. I just reset it. Yeah, so nothing happens. So if FFFF stands for run, so nothing happens because I just reset that. And I personally prefer hardware reset. And by the way, on the real device, well, and yeah, by the way, I'm developing the chess program I'm currently developing. I'm developing this on the real device, and because it's just easier, faster, and I just love touching this and pressing the buttons and just using the real serial port, and just, I don't know, this is so fascinating for me. Yeah, but it's just for demonstration. The simulator works better because just of a clear picture. All right, so I just want to show you a couple of programs I've developed for this computer. So, well, let's start, for instance, from the hello world. All right, so what happens? Yeah, by the way, yeah, just here is the source code for my chess engine already, by the way, so we'll come to this a little bit later on. But for now, let's just open this hello.asm. So here is how the Code Monkey assembly looks like, basically. So we have the labels. Yeah, recently, today, I've added the define statements. They were not available when the computer was just released. Yeah, so the commentary is explaining what in particular is going on here. Again, I have tutorials like how to code this hello world, explaining the details of how to code in this assembly, the processor architecture on this. It just takes ages to tell this one more time on this channel, so just go to my Code Monkey channel if you're interested. Just check it out there, please. All right, so what we need here, just to get familiar with the computer, so whatever label we have in the program, we just have the address for that label, and we just replace, obviously, like whatever assembly does, replacing the labels by these addresses. And here are the program bytes, so the opcodes are also being changed. So just have a look at the assembler. So whatever opcode we encounter, it just gets replaced with a corresponding opcode. So this is just a lookup table, and all the opcodes, again, like just listed right over in here. So again, like you can just use these guys to type from the keyboard, but if you want to write in assembly, you can use the mnemonics. And here are where the args are needed, and the size of the arg as well. So argument might be just either the memory address or the label, depending on what in particular you're trying to do. So I hope that's clear, right? And once I've assembled the program, it doesn't output the binary, but instead it outputs the bytes in the ASCII format. And we can just copy this and then go into the simulator, or alternatively, well, I'm actually developing this on the real, using the real Arduino hardware. So I'm using the serial monitor, I'm just pasting here, but you see, like, my Arduino is currently not connected to the USB ports, and it's not really working. So just to give you an idea how I'm doing this on the real hardware, but for you to try, you can just paste it here. It's literally enough. So this is the source code, like machine codes for the hello world program. And now if you just try to type FFFD, which stands for load program, waiting for input data, and then just click send, and it's just loading the data, and it's very laggy for some reason. So on the real hardware it works instantly. That's another reason why I'm debugging on the real hardware. And FFFF actually allows to execute the program, and here we got the hello world printed with a bit of a delay, replacing the cursor, so it's nothing really special. So the next thing that I've developed here is nope, hello, let me just show you the scroll. And scroll is inspired by Apple I computers. So there was a test program to run on Apple I computer. When the user just assembled that, it's intended to print all the ASCII characters and scrolling vertically. Well, here we have the horizontal scrolling instead, because LCD screen has the horizontal scroll. The hardware implementation for a horizontal scroll, and it would just be printing all the ASCII characters scrolling horizontally in the infinite manner. Okay, so this wasn't very impressive for now, I know. So the next thing we can have a look is how to work with the user-defined graphics. So I've created this little Mario walking across the LCD screen. So let me quickly demonstrate you how that works. So we can code up to we can code, what have I done? Shouldn't be doing this. So we can code up to 8 user-defined characters, and then we can do whatever we want with those characters, basically. So, for instance, we can make them to draw an arrow that walks along the LCD screen, and once it gets to the end of the screen, it just appears here, so it would be like the infinite scroll. Okay, so this is how the graphics work. So assuming that we have the graphical LCD shield, well, obviously this is the case, right? And yeah, Maro would be walking forever, basically. And this, again, not that impressive so far, I know. So the most outrageous thing I've developed for this computer is the port of the Chrome browser DINO game. So you know, like if you have your internet being turned off, so no internet connection, then you can play Chrome DINO game just right in the Chrome browser. And here is the version that I made for CMK Computer. So it takes up to, so it's quite huge. So you see, like it's kind of like 496 bytes, lots of labels, right? And yeah, like it works much better on the real hardware, but I'll just, so if you want to see that, you just have a look at the playlist that I've provided in the description below this one. And here in the simulator, this looks as following. So just loading another program, and I just send. And yeah, it's just very laggy for some reason, but anyway, it is gonna be working. And if we now just start the game, yeah, so it looks like a real game. So are you ready? And 0 is to jump, and here we can jump with the DINO, and we can jump over the cactus. And if we're lucky to do that, then yeah, we jump over the cactus. But if we're not lucky, then yeah, the game is over, which is predictable. So yeah, and yeah, then we can just restart the game from scratch, and every program should be able to restart from scratch. So yeah, it really looks cool on the real hardware, but yeah, it's not chess, and you're completely right, it's not chess. So, well, actually, initially, I was intended this computer to exactly be good enough to write a chess program on it, and the Chrome DINO was just a matter of debugging. Basically, I was debugging the instruction set, the assembly, the offset for labels, all of this stuff. There are really lots of things to consider there. And now, finally, I have just started basically developing exactly the chess program for it, and this is what is gonna be yeah, like the topic of the following videos, basically. So yeah, I think we could just probably we can end here. Yeah, and starting from the next video, well, we'll probably wait a little bit more until the PAL maybe gets some more better results. So yeah, starting from the next video, I will start covering, I believe, both the development progress and the design for my chess that is intended to run on this computer, and walking through the source code quickly and demonstrating the debugging process. So I hope that is gonna be fun. And for now, this is it from my side. So thanks for watching, guys, and until next time, and take care.